Welcome to our presentation about the Master Specialization Mathematics at Radboud University. My name is Stefanie Sonner, and together with my colleague Steffen Zagave, we would like to tell you about the Master Program in Mathematics. We point out the characteristic features of the program and the opportunities you have when doing a Master in Mathematics here in Nijmegen. Steffen Zagave is an assistant professor in pure mathematics. His main research field is algebraic topology, and I'm an assistant professor in applied mathematics, doing research in applied analysis. We represent two of several different research areas in our department and the fields you can specialize in when doing a master in mathematics. I would like to point out that this presentation focuses on the master specialization in mathematics. But you can also combine a master in mathematics with a societal focus and do one of the three societal specializations. These are science in education, science in society, and science management and innovation. Those specializations are presented elsewhere. A master degree in mathematics opens the door to a wide range of career paths that ranges from doing actual research in mathematics through to working in biology, neuroscience, climate change or finance. In fact, a master in mathematics trains you in analytical and abstract thinking and problem solving, and these are skills that are in high demand nearly everywhere. Therefore, having a master's degree in mathematics provides you with excellent job opportunities in a variety of different branches. The master program in mathematics in Nijmegen is a broad program with different focus areas. We have 6 master tracks. These are 3 core tracks that represent the main research directions in our department: pure mathematics, applied mathematics, and mathematical physics. And then we have 3 synergy tracks. Synergy tracks are interdisciplinary tracks that combine courses in mathematics with courses from other fields of science and take advantage of the unique expertise in these particular fields at Radboud University. The synergy tracks are mathematics of computer science, mathematics and data science, and gravity plus.
The master program in mathematics at Radboud University Nijmegen has many strengths. You study in small classes with very approachable teachers who know their students. There's a lot of individual supervision during your master studies. We have a young faculty that is mathematically broad and enthusiastic about both research and teaching. The mathematical broadness allows you to specialize in many different areas. We can offer you a wide range of choices and a large variety of courses that you can choose from, and so you can build a program you like for your master studies. There are interdisciplinary tracks that combine mathematics with courses from adjacent sciences. We have an excellent infrastructure, for example, a pretty new building with a lot of study places that are used by many of our master students. Moreover, we have an extremely active study association for the mathematics students called DESTA that organizes lots of activities.
The setup of the master specialization mathematics at Radboud University is the following. We have 3 core tracks and 3 synergy tracks. The core tracks represent the 3 main research directions at our department. Those are pure mathematics, applied mathematics, and mathematical physics. Then we have the synergy tracks. These are interdisciplinary tracks that combine courses in mathematics with courses in different fields of sciences. The synergy tracks are mathematics of computer science, combining courses in mathematics with courses in computer science. We have mathematics and data science. This is a track that combines courses in mathematics with courses in computer science and physics. And then we have the track Gravity Plus that combines courses in mathematics with courses in physics and astronomy. We present here only the master specialization mathematics, but you can also combine mathematics with one of the 3 societal specializations. That means you have a reduced number of courses in mathematics and in addition you take courses with a societal focus. The societal specializations are Science and Education. This is a program taught in Dutch and aimed at students that would like to become high school teachers. Then we have Science in Society and Science Management and Innovation. Those specializations are presented elsewhere. Independent of the track you choose, the master program in mathematics has the following structure. It is a 2-year program with a total study load of 120 EC. The study program has a very few mandatory courses. That means you have a lot of freedom and flexibility to choose the courses that you like. You can build up your own individual program based on your interests and personal preferences. I would also like to point out that you have the possibility to change tracks due to this large flexibility of the program in case you started the program and notice at a later point that you would like to change your specialization. Among the mandatory courses is the master seminar. This is a common activity that brings together all first-year students in the master, so you have the chance to get to know each other, and apart from a training in mathematics, it provides you with valuable transferable skills, such as communication and presentation skills. The other mandatory courses in the master program are a course in philosophy and professional preparation. The mandatory courses add up to 11 EC, and that's a small portion of the total amount of 120 EC. Then you choose one of the 6 different tracks we offer, and for each of those tracks you have a list of track elective courses from which you can choose a total number of 30 EC. Then there are elective courses from which you have to choose 39 EC. These elective courses can be courses in mathematics, but also courses in different disciplines. The final piece of the program is a master thesis that accounts for 40 EC and is written in the 2nd year of the program. The master thesis is supervised by one of the staff members and of our department and can be written in one of the research groups at our department or as an internship in a company or governmental institution. In case you would like to do an internship, Radboud University has contacts to many companies and can help in finding a suitable project.
We now present the 6 different tracks of our master program in mathematics. Pure mathematics is primarily concerned with questions that originate from inside mathematics, for example, about algebra, geometry, or number theory, although these questions can also have relevance for other sciences. Examples of track electives for the pure mathematics track are algebraic topology, Lie algebra, Lie groups, algebraic geometry, differential geometry, Riemann surfaces, elliptic curves, analytic number theory, or calculus of variations. These track electives reflect the different research areas in pure mathematics that are represented at Radboud University, Nijmegen. You can specialize in these areas and write your master thesis about one of the subjects. The research areas include algebraic geometry, where there's, for example, research about abelian varieties and moduli spaces, algebraic topology, where there's research about homotopy theory, arithmetic geometry and number theory, differential geometry, where there's research about Poisson geometry, logic and computer algebra, and representation theory and Lie theory, where there's research about Hacker algebras and the famous Langlands program. The synergy track Mathematics of Computer Science combines courses in pure mathematics with courses in computer science, following a long tradition of collaboration between these 2 departments at Radboud University. The track electives have one mandatory course, and that's the course on computer algebra, and then there are other track electives such as semantics and domain theory, experimental mathematics, automated reasoning, and type theory and Coq. The synergy track Mathematics of Computer Science is very well suited for students who hold a double bachelor degree in mathematics and computer science, but you can also study the synergy track without such a double bachelor degree.
The core track Applied Mathematics covers the modern mathematical theories and techniques that are needed to model, analyze and investigate phenomena in other fields of science. That ranges from biology, neuroscience to fundamental physics. Examples of track electives in the Applied Mathematics track are courses in applied analysis, such as the calculus of variations, mathematical biology or optimal transport. We have courses in statistics and probability theory, such as probabilistic combinatorics, regression analysis, or biostatistics. And we have courses in numerics and scientific computing, such as Monte Carlo methods, finite elements, and stochastic simulation. The track electives in applied mathematics reflect the expertise and research interests of the research groups Applied Mathematics and Applied Stochastics at our department. We do research in applied analysis, focusing on research in calculus of variation, in infinite-dimensional dynamical systems and nonlinear evolution equations. We also do research in applied stochastics, including the research areas statistics, combinatorics, and probability theory. And we have staff members working on numerics and computation, doing research in stochastic differential equation, optimization, uncertainty quantification. Our applications that we consider include applications in geosciences, imaging sciences, mathematical bioscience, and nonlinear wave equations. We also work on interdisciplinary projects in collaboration with other departments, for instance, the economy department or the cell biology department. In the synergy track, mathematics and data science, you study the modern disciplines in computational modeling and data science that play an increasingly important role in modern science as well as in industry and society. The synergy track Mathematics and Data Science combines courses in applied mathematics with courses in physics and computer science. Examples of track electives are the courses Machine Learning, Data Science, Computational Neuroscience, or Regression Analysis and Non-Parametric Statistics. At the Faculty of Science at Radboud University, we have several leading scientific centers that use these techniques, such as machine learning and artificial intelligence techniques, in their research, such as the Donda Center for Neuroscience, the Institute for Computing and Information Science, and the Astrophysics Department.
The core track Mathematical Physics focus on areas that lie in the overlap between mathematics and physics. For example, in general relativity, non-commutative geometry, and quantum field theory. Examples of track elective for this track include functional analysis, non-commutative geometry, differential geometry, partial differential equations, or quantum computing. These track electives reflect the research areas in mathematical physics that are present in Nijmegen. For example, differential geometry, where there's research on geometric analysis, general relativity, quantum groups and representation theory, or non-commutative geometry, where there's research on Thie-star algebras. The core track Mathematical Physics is ideal for students that hold a double bachelor degree in mathematics and physics, but it is not required to have such a double bachelor degree to study this track. The synergy track Gravity Plus reflects the unique expertise in the mathematics and astrophysics of gravity that is present at Radboud University. You've all seen the now famous first picture of a black hole in whose creation researchers from Radboud University played a crucial role. The track electives for the synergy track Gravity Plus include general relativity, gravitational waves, singularities and black holes, or nonlinear wave equations, or quantum gravity. Since this synergy track combines courses in mathematical physics with courses in physics and astronomy, it is recommended that you bring a double bachelor degree in mathematics and physics because previous knowledge in both areas is required to study this synergy track.
We have a broad range of local courses and you can fully study your Master in Mathematics in Nijmegen. But you can also participate in Mastermath. Mastermath is a joint program of several Dutch universities and offers about 50 master courses each year. Some of the courses are taught in Nijmegen. For other courses you have to travel to other universities or follow them online. For those courses that you follow a different university, we provide local support in Nijmegen. Mastermath offers a large selection of courses in mathematics of different levels and brings you together with students that have similar interests. Another important factor that contributes to the enjoyable atmosphere in Nijmegen is the study association, DESTA. DESTA is very active and organizes a broad range of activities throughout the year. Often staff members participate and many activities are related to mathematics, but certainly not all of them.
Having finished a master degree in mathematics at Radboud University Nijmegen, you have excellent job opportunities. We have made the experience that our students find interesting, highly qualified and typically also very well paid jobs shortly after graduating. It is also important to note that the chosen specialization area during your mathematics studies is hardly relevant for your job opportunities. So you can choose the area of specialization according to your interest without committing yourself on a specific area to work in later. Typical branches in which our graduates find jobs include the IT sector, banking, insurances, consulting, management, the public sector, and also education. Some of our graduates also continue with a PhD in mathematics here in Nijmegen or elsewhere in the world. It is also important to note that some of our students use the Master in Mathematics as a basis for a research career in an adjacent area like computer science or economics, since we've seen several students starting with a PhD in this direction. Last but not least, we would also like to mention that there's a Radboud Career Service that supports students in finding a job after graduating.
A certainly important prerequisite for doing a Master in Mathematics is that you enjoy mathematics. On the formal side, the central prerequisite for the Master in Mathematics at Radboud University is a bachelor degree in mathematics or a closely related area. The master program in mathematics is taught in English, and international students may have to prove proficiency in English. Detailed information about the admission requirements you find on the website.
For more information about our master program in mathematics, we recommend that you consult the web pages of the master program. If you have specific questions, you can contact us via email. You can also get in touch with the study advisor, Ina de Vries. We thank you for following this presentation and hope to see you as a master student in Nijmegen soon.